Hello, everybody. My name is Matthias Fischmann. I've been working on a web application with Andor and Nicolas, a couple of other people. I'm going to talk about the code mostly. I have to apologize in advance that this will be a bit disorganized. My laptop died last night, and I have to use a slide set that is not perfectly prepared for 10 minutes. So there are a couple of screenshots of the web application that I have to glance over. It's a discussion forum with voting, and this is the landing page that we're going to see some code for. Just giving a list of chat rooms, essentially, that you can go in. And then there's ideas that you can discuss and vote on, and there are user profiles, and you can delegate your votes and view the delegation network. But I mostly want to talk about the code in these few remaining minutes. So this is where you can get the code. This is what we used. So it's very old-style, multi-page app. The HTML code is entirely generated on the server side. There's very little JavaScript code running in the browser. We use Servant to deliver the HTML code, Lucid for generating it, and digestive-functors for getting input from the user in web forms. And there's other stuff that I'm going to skip. So I'm going to talk about Lucid, Servant, and digestive-functors and how they all fit together for the rest of the talk. For every page, this is a non-interactive page to begin with. It has links, but it doesn't take user input. You define a data type that contains all the application data needed for rendering the HTML. And this is the page you've just seen that lists all the chat rooms called idea spaces. And Lucid lets you define HTML code inside Haskell, so it's an embedded DSL, defining the names of all the HTML elements and attributes with underscores. And you can use Haskell syntax and Haskell control structures and all that to define your HTML code. So this is how it works. You have a toHTML class that you instantiate for the pages that you want to render, and then you just write HTML in a slightly different syntax. And this is the introduction code of the page that you've seen in the beginning. So it gets a bit more concise than most templating languages because you can use map and define functions for things that happen over and over again and so on. There's also Blaze, which is a predecessor of Lucid, I think, and they share some code. Blaze is supposed to be faster. We haven't measured that, but it doesn't provide a monad. So you've seen the do here. And then the list of children are all stored in a writer monad and then constructed into a string. And if you try to use bind for internationalization, or if you want to build any monad transformer stack on top of HTML, then Blaze will not let you do that. And also the syntax of Lucid is slightly nicer. So we use that. Quick show of hand, who has used Lucid before? Okay, who has used Servant? Okay, that's good. So I can do it in one slide. This is an unfolding slide, but it's really very, very brief. So Servant is a DSL for defining APIs, HTTP APIs, as lists of endpoints with routes and methods and the types of the requests and the responses. And this is a very simple one. It takes a path space, so you have just one path segment. The request method is get, and this is the type of the result. We've already seen that Lucid can turn that into HTML code. So, and you can do slightly more complicated things like read path segments or query parameters, and then you get URLs like this. But it's essentially the same thing. And then you can compose those, and you can write very abstract handler functions for that. And all the request parsing and response construction happens inside the types. So you only have to define some action that constructs the application data, and rendering will happen in the background. or if you have variable parts in the route, then you get a function that has to construct an action. So usually servant is not used for HTML. It's supported. There are other types for it, but I haven't heard anybody use it extensively before this, and this is, I think, the first production system. So we've concluded that it works, and you just have to summarize a page type and a servant endpoint and handler and a 2HTML instance, and then you have the static content. And if you want to get input from the user in web forms, then it gets slightly more complicated. So in that case, again, we need to define a type for the page to describe the shape of the form contents and also of the rendering, like the page. We need to define the rendering again. So this is both not very different from what we did for static pages, and it uses lucid again, only in a slightly more involved way to render the validation errors and all that. And then we also need a validator. And so we start with a slightly different page, and I'll walk you through a simple application of digestive functors with servant and lucid. This is the type. And then we have lucid code again. This is different. This is digestive functors, and it gives you a form field, and you see that there's a string that gives a key to the form field that we need for validation later on. And you have these two extra arguments. This contains the information about the form, like validation errors and things that the user has entered, default values, actually. And form is the thing that the library gives you to turn these into actual HTML code. Like get the identifiers right for the request to be formulated correctly and all that. And then you need a validator. And the validator will output a thing called payload. And there is a type family that I have skipped over in these slides that is determined by the page type. So every page type has, if it's a form, a payload type associated with it, and the make form validator constructs a value of that page, of that payload type, by sticking smaller validators together. And here you see the keys of the input fields again. So at this point, we can render the form, we can validate it and construct the output. And this is just standard digestive functors code, and there is a very nice tutorial to that. So if you're not familiar with that, it's better explained elsewhere. And we stick those together in a type class called form page. And then we need two more things to run this, which are the actual handlers for get. So where do I get the page value if somebody wants to render a form? And what do I do with the payload when somebody posts the payload and it's been validated? Now I have to jump back and forth. So there's one extra thing called hooks that you have to construct. And the two things you always have to give is what I just said, like generate page data. And I just pull one out of my sleeve with quick check here and process the payload. And I do something not so interesting either, but usually you would write it to the database or do the appropriate thing with it. And that's what the application has to say. It has to say, what does the page look like? How do I parse the data? Where do I get pages from? And what do I do with the payload? And then you can just do this. Now back to servant. We have one endpoint. I'll get to that in a moment. That is called form handler and is marked by the page type again. And the handler is now completely defined by the hooks and the class dictionary already. So there's nothing else we have to add that we couldn't add in the hooks if it's some special thing like CSRF protection. Yeah. And the form handler is actually interesting because it's 2 endpoints, not 1. We need to be able to both get and post, but we can hide that behind a type so we don't have to worry about what forms that they add these 2 endpoints anymore. And this is then just part of a general purpose library that we're in the middle of developing that you don't have to worry about the internals either. So just takes some hooks and gives you a server or a handler. And I think I'm out of time, or at least that's what I expected. So I'm not sure. How long was I talking? Sorry?
It's time.
It's time. Okay. Okay. Thank you. Next one. I don't know.